Okay, welcome back. Hopefully you were successful. So I'm just going to go over this real quickly, make sure you guys are on the right track. So we have a problem here where you have to subtract two measurements, and then you divide that by a third measurement. And of course, in this example, we're trying to find the density of this sample. So we're getting grams per mil. So the first step, I would take the 80.21, and we're going to subtract the 79.93, and you should get 0.28. And since we have hundredths place in both of those measurements, we want to end up with the hundredths place in that answer. So notice that even though we have 4 sig figs in those two measurements, we only end up with 2 sig figs in that final answer. So again, because you're subtracting or adding, it's based on the decimal places, not the total sig figs. But now we're going to take that measurement, or that answer, and we're going to divide by that 65.22 milliliters. And if you put the answer that you get on your calculator, you may get something like this. So now the question is, well, how would we express that with the right number of sig figs? So again, now we have division. So we're going to take 2 sig figs, we divide it by 4 sig figs, and so when it's multiplication or division, you use just the number with the least number of sig figs. So we have 2 sig figs here. We want to have just 2 sig figs in our answer. And of course, if we round, we see that we have 9, which is a number bigger than 5, and so we're going to round that up to 0.0043 grams per milliliter. So answer choice C would be your correct answer. So B would be an answer that's close, but if you're using the correct number of sig figs, then of course you have to go choice C. All right, so now that we can deal with sig figs and rounding, we want to move on to dealing with numbers in exponential form. So this is another very common skill that you want to be practiced with as you go into Chem 1. So the question is, well, why do we want to use exponential form? So I think I have a couple of examples. So first, if we have numbers that are very large or very small, so some number that's much larger than 1. So here we have, for instance, 1,700,525. So we want to sometimes be able to express that number in a way that we don't have to write out so many digits. And of course, we have a number that's smaller than 1, so some decimal or some fraction. That's even more, it's even more convenient sometimes to use scientific notation. So instead of writing all of these place-holding zeros, we want to be able to just write a number that's more succinct. So for these two examples, hopefully you are practiced in scientific notation from your math class, but I want to make sure. So hopefully you remember that if you take the decimal place, you just need to count over until you get to the last 2 digits. So this would be 1.7 times 10 to the 6th. So of course we have a number that's much larger than 1. You should have a positive exponent. And again, you just want to take notice that we would want to report this to the correct number of sig figs. So using the scientific notation helps us report this. So for instance, we only need 2 sig figs. It'd be hard to write this number with 2 sig figs without scientific notation. All right, and then we want to take the number smaller than 1. Whoop, 1 too many. So now we want to take that decimal place and end where we have one digit to the left of the decimal. So now we'd have 5.75. We went 1, 2, 3, 4 places, so 10 to the minus 4. So again, hopefully you remember that if you have a number less than 1, then you have an exponent that's negative. All right, so hopefully you can see the difference. So instead of writing out this very large number, we've kind of made it more succinct by using scientific notation. And instead of trying to deal with all these place-holding zeros, we're now just representing what are the significant digits in that measurement. All right, so we want to think about how can you deal with calculations using numbers with scientific notation or dealing with these exponents. So we'll do an example of that in just a second. Okay, so welcome back. We're going to do 3 examples of calculations where we have numbers with exponents or scientific notation. And I'm going to show you a couple of tricks. Hopefully you have a calculator, a scientific calculator, where you can input scientific notation, but it's always good practice to think about how could you do these calculations if you don't have that, or sometimes your calculator malfunctions on an exam. And so if you just have basic multiplication and addition, subtraction, division functions, this is a way you can do it. So I'm going to just show you a couple of quick tricks that I learned that have stuck with me to this day. So the first example, we're going to multiply these two numbers. So 2 times 10 to the third times 9 times 10 to the second. So if you're not using the exponent form on your calculator, what you could do is you would, of course, multiply the two numbers. So you would multiply the two numbers, which would give you 18. And of course, if we have 2 sig figs in each number, we should have 2 sig figs in that answer. And then when you multiply, you're going to add the exponents. So that would be 18 times 10 to the 5th as your answer. Now, of course, you hopefully recognize you don't normally express scientific notation with 2 digits before the decimal. So we want to show this as a normal scientific notation. So we're going to turn that into 1.8. And so this is a trick you can use. So we made the decimal, we moved it so that the number became smaller. So we had to move this decimal here. So we made the number smaller so the exponent becomes bigger. So 18 times 10 to the 5th is equivalent to 1.8 times 10 to the 6th. But this is the way you would want to show that answer on your quiz or your test, because you always want to have one number before the decimal. Okay, so when we divide, similar approach. So of course now we're going to divide those two numbers, which would give you 2.0. And when you divide, you're going to subtract the exponents. So 5 minus 3, that gives you times 10 to the 2. So in this case, you end up with an answer that has the decimal point in the right position. This is correct scientific notation, so you don't have to manipulate that. All right, so if your calculator exponential function is not working, these are little tricks you can use to hopefully get you by. All right, finally, let's say we want to add or subtract two numbers. So the trick here is you can't add or subtract numbers if the exponents aren't the same. So we would want to change that number so that we can express it as a 10 to the 3rd power, so that it now matches the first number. So we could then say 2.0 times 10 to the 3rd. We're going to subtract 0.10 times 10 to the 3rd. So the same rule. If we want to make this exponent bigger, we have to make the number smaller. So 0.1 times 10 to the third is equivalent to 1 times 10 to the second. So now all we have to do is subtract these two numbers. So 2.0 minus 0.1 equals 1.9, and that's going to be times 10 to the third. So when you add or subtract, the exponent stays the same. And that's already in correct scientific notation. All right, so now if you have a scientific calculator, you can input those into your calculator, hopefully. There are different types of calculators that you might encounter. And so what I've done here is I've provided two different links that have YouTube video tutorials where you're being shown how could you input the exponents into your calculator so you can then multiply or divide or add or subtract. So you can check those out, and if you have more questions beyond that, you can get in touch with me via the discussion board on the iLearn. All right, so go check those out, and then what I want you to do is go try this practice problem. So now you're being asked to divide two numbers in exponential form. I would recommend that you try doing it first the longhand way without using your scientific calculator, and then use your scientific calculator as a way to double check. So work on that, pause the video, and when you're done, come on back and we'll go through the solution.